Hello friends, welcome to Susan and John MathTube. This is lesson number 16 in the examination preparation series for the first year engineering students. And we are at improper integrals. And as always, the most important 5 points. And I hope you are focusing on point number 1 and point number 2. They are very important. And of course, here we go with the other points. And let's start. So, I hope you remember we were discussing improper integrals type 1. And type 1 is very easy to identify because one of the limits will be infinity. And we do a simple trick. We change this problem into an approximation problem. We change it into a limiting problem and we find the limiting value. Sometimes the answer will be infinity and sometimes the answer will be, plus or minus infinity, and sometimes the answer will be finite. If the answer is infinite, we say the integral is divergent. And if the answer is finite, we say that the integral is convergent. Let's start with a problem. So please write, evaluate the improper integral. Integral 2 to infinity dx by x square minus 1. That's it. So we have worked out a lot of questions. So I want you to try this question by yourself. So I'll give you the formula so that you will be able to integrate. Integral 1 by x square minus a square. This is 1 by 2a log mod x minus a by x plus a. If you want to use the formula directly, it's a good idea. Otherwise, you'll have to change this into partial fraction. But I'll strongly recommend this method because it's you can apply it directly. So, integral 1 by x square minus 1 dx will be 1 by 2 into 1 log mod x minus 1 by x plus 1 plus c. So, you have the integral. Second thing, I'll give you a hint what to do on this side. You change this into a limiting problem. Limit t tends to infinity. Integral 2 to t. 1 by x square minus 1 dx. Now you integrate. You will have to apply the formula. Log a minus log b equal to log a by b in the middle of the problem. And another very important thing is you have to understand log 1 by a is the same as minus log a. And sometimes you have to understand minus log a is log 1 by a because we will be frequently using this from this direction to this as well as from this to this. Anyway, the answer is 1 by 2 log 3. Okay. So try it and comment whether you got the answer or not. If so many people are struggling, of course in later videos I'll add this or I'll add the solution in my website. So please do try and comment below whether you're able to do it yourself and whether you got this answer or not. Okay, let's move ahead for the next question. Okay, so please write. Evaluate the improper integral. Integral minus infinity to infinity x by x to the power 4 plus 1 dx. Clearly, it is given it's an improper integral. Even if they don't use the word improper integral, you will be able to understand by just looking at the limits. Okay, now what we do is on one side of your copy, you write the integral without limits. Okay, and now let's think how to integrate this. I think you are able to see a function and its derivative, because whenever we have a function and its derivative, the best method is substitution method. I am able to see the function and part of the derivative. So look at this, what I did is I made this x power 4 into x square the whole square. If you ask me why, I'll explain like this. If I put x square is equal to t, whenever you make a substitution, you remember the next thing to do is you have to change the limits if it is a definite integral. But currently this is not a definite integral, so we are not going to do that. And another thing you have to do in both is you have to find the differential. See, 2x dx equal to dt. Yeah, that's the main reason I did that. See, we have x into dx. I was able to see that in the beginning itself, and you'll be able to do this integration only if you are able to see that part. So this is 1 by 2 dt. Now shall we substitute and integrate? So the numerator becomes 1 by 2 dt. The denominator becomes, look at this, x square is nothing but t. And this 1 by 2 goes outside, and now I am not going to explain more. Or no, I'll ask my usual question, because I know some of the students who are watching this video might be very weak in integration. So it might be helpful for someone. So tell me, what is the derivative of tan inverse x? 1 by 1 plus x square. So what is the integral of 1 by 1 plus x square? Tan inverse x. Okay, with this information, I'll be able to integrate. This 1 by 2 goes outside, and I can see 1 by 1 plus t square, whose integral is tan inverse t. But who is our t? I'll circle it with white. Yeah. So this is actually equal to 1 by 2 tan inverse x square plus c. Okay, there we go. The integration is finished. So this is compulsory, and please do it neatly in the examination. Okay, if you are doing it in the middle of the page, make sure you put this inside a box. Okay, now let's move ahead to the main part. So what should we do? We should convert this into a limit problem. So a tends to minus infinity, b tends to infinity, integral a to b x by x to the power 4 plus 1. Okay, now we already have the integral value. Okay, so I will do that plug-in the next page. So I end up with I is equal to integral. So I end up with integral limit a tends to minus infinity, b tends to infinity, integral a to b. Okay, we already know the integral value, so we are going to put, what's the answer? Yeah, 1 by 2 tan inverse x square within the limits a to b. Okay, I'm going to keep this 1 by 2 outside. So 1 by 2 limit a tends to minus infinity, b tends to infinity, tan inverse b square minus tan inverse a square. Okay, so now we are going to plug in the value of a and b, so they will get squared. And I hope you remember tan inverse infinity is 90 degree, and 90 minus 90 gives us 0. So we have our conclusion. The given integral is convergent. So what happens to the given integral? It is convergent, and it converges to 0. So let's move on to the next problem. The next problem is very, very important, and you'll understand the importance when we move on to the next topic. Once we complete improper integral, we will be moving towards a very important topic, exam point of view, that is called differentiation under the integral sign. Okay, so before we start the next problem, I want you to note this thing. Integral e power ax into cos bx dx is e power ax the whole divided by a square plus b square a cos bx plus b sin bx plus c, and integral e power ax sin bx is actually e power ax by a square plus b square a sin bx minus b cos bx plus c. So I want you to note these formulae because you should be very good with this. And we have to discuss one more small thing. So I think instead of discussing this in the middle of the problem, we will do that now. Okay, look at this. This is the graph of sin x. Sin 0 is 0, sin 90 is 1, sin 180 is 0, sin 270 is minus 1, and again 0. And you have learned the graph of sine. This is the life of sine. It keeps on going like this. And the maximum value it will reach is 1. And the minimum value that it can go is minus 1. So here we have 180 degree, 360 degree, 360 plus 180. You calculate. Yeah. So it keeps on moving like a wave. So even if you calculate sine 900 degree, or sine 9000 degree, or maybe sine 13,420 degree, or maybe sine 1,40,000 and something, etc., etc., etc. Your answer will be between minus 1 and 1 because the height keeps, this is the same thing which is going to repeat. So you have to understand a fact, sine infinity is a finite number. Sine infinity is a finite number. Look at this. Let it be 900, let it be 9,000, let it be 13,000, let it be 1 lakh, let it be 10 lakh, whatever. The answer will be between minus 1 and 1. So please note one very important fact. Sine infinity as well as cos infinity, because sine and cos are like what you call two runners which started the race a little bit at different times. Basically the graph of sin x and cos x are the same. If you pull this graph a little bit backwards or if you push this graph a little bit forwards, just imagine I have drawn till minus 90. You push the graph of cos x forward and you'll see the exact replica of sin x. So basically sine infinity and cos infinity are finite numbers which lie between minus 1 and 1. So remember, if you ever get 0 times sine infinity, don't get confused. You write the answer 0. Okay, so let's move ahead, and the next thing I wanted to show you is the graph of the exponential function. After this coronavirus incident, I'm sure so many people know about the exponential graph. It is called a hockey bat because the graph of the exponential function comes like this, and everyone knows e power 0 is 1 because any finite number to the power 0 will be 1, and then the growth rate becomes so high. You can check the coronavirus graph. Nowadays it's trending everywhere. So it goes like this, it goes like this, it goes to infinity. So basically it looks like a hockey stick. It looks like a hockey stick. So what I'm trying to convince you here is, when we move towards bigger numbers, the function value becomes so bigger. So you have to understand e power infinity tends to infinity. At the same time, at 0, that is e to the power 0 is equal to 1. And on the negative side, look at this, the height of the graph decreases, but it can never touch the x-axis. So e power minus infinity tends to 0. So if you remember this hockey stick, you will never forget the values. And if you don't want to remember the graph, you just remember these, these values. Okay, so let's start with the next question. So I'm sure you know the question because I had been talking about that e power x and cos bx. So please write, evaluate the integral 0 to infinity e power minus ax sin bx dx. So shall we start? Yeah. So the first thing to do, on one side of your copy, you write e power minus ax sin bx dx without any limits. And I already gave you the formula, but please be aware there is minus a instead of a. So we get e power minus a the whole divided by minus a the whole square plus b square, and it will be minus a sin bx minus b cos bx plus c. Anyway, you write the formula. Okay, and on this side what we do is, we already identified this is type 1 improper integral. So we convert this type 1 improper integral into a limiting problem. That is, we write limit t tends to infinity, integral 0 to t e power minus ax sin bx dx. We already know the integral. So all you have to do is you have to plug in that value. So we get limit t tends to infinity. Look at this, there is this minus coming outside. I think you're able to see that minus coming outside. So I'm going to put that minus here. Minus e power minus ax by a square plus b square and a sin bx plus b cos bx within the limits 0 to t. And I'll put some yellow circles wherever you have this x. And we can keep this minus 1 by a square plus b square outside the limit. So basically we end up with minus 1 by a square plus b square. I'll show you that step once more. Yeah. Limit t tends to infinity. Okay, plug in time. So I want you to plug in the upper limit. E power minus at a sin bt plus b cos bt. Okay, now you plug in the lower limit. So when you plug in this lower limit, this will be sin 0. Sin 0 is 0 and cos 0 is 1. So you end up with b. So all you get is 0 plus b. I'm going to write b. Okay, now time to apply the limits. If you want, you can split this into two limits, but I think it's not necessary. Look at this. We have minus 1 by a square plus b square. And this is going to be 0. I already showed you the hockey stick. And we get e power minus infinity. I always remember the graph of exponential function using this hockey stick. E power 0, that is 1. And then it shoots to infinity. So e power minus infinity is 0. So this will be gone. And sin infinity, cos infinity are finite numbers. So you get 0 into something finite. So that becomes 0. That's it. So we end up with minus b over there. And the answer is b by a square plus b square. So this question is very important. Please make sure you practice a lot of times. Anyway, I'm going to give you one more question of that type. You can do it yourself. Evaluate the definite integral. Actually, it is an improper integral which is definite. e power minus ax cos bx, where a is a positive quantity, because if you don't mention a is positive, then this whole thing can become different. I'll give you the answer. You try this and comment below. If you have any difficulties, I'll help you with it. Or you can email me, or you can visit our website. Yeah, the answer is a by a square plus b square. Okay, let's go for the last question in type 1. After this, we will learn type 2, and that will be in the next video, of course. So please write, evaluate the integral minus infinity to infinity e power x by 1 plus e to the power 2x. Okay, so as always, what's the first thing to do? Write the integral without limits. Anyway, I'm going to manipulate because I already noticed a trick to integrate. I can see the function and the derivative. So as expected, I'm going to put t is equal to e to the power x. So dt will be e to the power x dx. So this e to the power x dx should be replaced with dt. So we get dt, see, e to the power x dx by 1 plus t square. And just now we discussed 1 by 1 plus t square is tan inverse t, and t is nothing but e power x. I'm skipping steps. If in case you have any doubt, please feel free to email me. Okay, so here we get limit a tends to minus infinity, b tends to infinity, integral of this quantity, which will eventually become tan inverse e power x, and that will become e power b minus e power, tan inverse e power a. I'll repeat, I skipped a lot of steps, I know that. Okay, now you plug in the limits. Again, draw the hockey stick. E power minus infinity is 0, e power 0 is 1, e power infinity is infinity. Okay, so this is going to be infinity, so you get pi by 2, and this is going to be minus infinity, so you get tan inverse 0, which is 0, so the answer is pi by 2. Okay, so I'm going to wind up this video here. In the next video, we will learn one very interesting type of improper integral, and that is called improper integral type 2. And in the last video also I asked one question. Did you evaluate integral 1 by x square dx between minus 1 and 1? Try it, keep on trying it. But we'll be discussing about this very soon. Okay, so if you like the video, please like, share and subscribe. So I'll be back very soon. So till then, my friends, bye.